Number one, a stationary ball is hanging from a like string. A pellet from an air rifle is traveling horizontally and becomes embedded in the ball. The velocity of the pellet when it strikes the ball is 160 meters per second. This is the diagram part of the pellet, and this is the ball. The following data are given as information about mass of the ball: 250 grams, mass of the pellet 2 grams. So the pellet inside the ball. The pellet mass is 2 grams and the ball mass 250 grams. So total 252, 252 grams. Calculate the speed of the ball and the pellet immediately after the impact. Okay, so I would like to convert a gram to kilogram. It is becomes 0.25 kg, and this one becomes 0.002 kg, while the velocity of pellet here, the pellet velocity is 160 meters per second, according to this information. Okay, and the velocity of ball, the ball velocity is 0 meter per second. According to conservation of momentum law, that I would like to write in here that NB times VB velocity, ball mass times, this is not minus, this is not minus but multiply. Ball mass multiply ball velocity plus, this is before collision. Okay, mass pellet times pellet velocity is equals is after the impact. Ball mass plus pellet mass times the velocity after. Okay, because we are going to calculate the speed or velocity. And the velocity after, if the velocity after the subject, it means this formula becomes mv times vb plus mp times vp over mv plus mp, and becomes mb is this one 0.25, pb is 1 times 0, mp mass of pellet is 1 0.002 times vp 160 over 0.25 plus 0.002. And if you calculate, becomes it is 0 plus 0.32 over this one 0.252 and it's equal 1.27 meter per second, or rounded becomes 1.3 meter per second, one decimal place. Next, suggest why the combined kinetic energy of the ball and the pellet after the impact is less than the initial kinetic energy of the pellet. Uh, I have written my opinion, my solution. This one. Okay. So wait, I have to here. Okay. After the pellet embeds into the ball, both the ball and the pellet move together as a single object. The system uh, I'm going to clean this area first. Okay. So after the pellet embeds into the ball, both the ball and the pellet move together as a single object. The system's total mechanical energy or kinetic energy decreases because the combined system, which are ball and pellet, it will move with a lower velocity than the pellet's original speed, since the mass of the ball is much greater than the mass of the pellet. This results in a lower final kinetic energy compared to the initial kinetic energy of the pellet. I think clear. Next. The ball with embedded pellet rises to a maximum vertical height, h. This is diagram. This is h. Draw and label the free body diagram for the ball at height h. Okay. So this is the tension's direction to upwards. Okay, this is the tension, while the weight to downwards. Okay, so tension T is acting. It is acting upward along the string, while weight due to gravity acting the direction to downwards. Number two, a student throws a ball towards a wall. The ball is released from a point 1.8 meters above the ground and 8.0 meters from the wall. The initial velocity of the ball makes an angle of 48 degrees with the horizontal. A resistance is negligible. The diagram shows us the initial path of the ball. The initial path. P is a point on the path. This is the point P. It's the diagram. And then what else? Draw on the diagram an arrow to show the velocity of the ball at P. Label this arrow V, velocity. So this is what I'm going to use in the different color. This is the arrow. Sorry. Okay, this is the arrow. Okay, v velocity. The accelerations of the ball at P. Label this arrow A. So the acceleration to downwards because of gravitational force. Okay, this is the acceleration A. Next question. The ball takes 1.3 seconds to reach the wall. The initial speed of the ball is 9.2 meters per second. Determine the height above the ground at which the ball hits the wall. Okay, so I'm going to identify first that the initial height is h0. This is the initial height, 1.8 meters. And next distance from the wall is 8.0 meter. Angle angle or angle theta is 48 degrees. And time, this is time to reach the wall according to the information that 1.3 seconds. And then V0 or the initial speed of the ball. The ball initial speed is 9.2 meter per second. And then acceleration due to gravitational force is 9.8 meter per second squared. And after that, uh, I'm going to determine the horizontal component. So there are two components acting on this phenomenon, uh, yeah, on this ball. Okay, so the component are horizontal component and vertical component. The horizontal component is V0x. It is V0 times cosine theta. V0 is 9.2 meter per second times cosine 48. And if you calculate 6.16 meter per second. And after that, the vertical component represents by V0y, V0 times sine theta. But I write here, this is the horizontal component. Let's find the vertical component, 9.2 times sine 48. And if you calculate, the result is 6.83 meter per second. This is the vertical component. Okay, the vertically component. Right. As the horizontal motions described by, I have to write in here, the horizontal, because this important information, the horizontal motion So necessary to me to write here is described by the equation uh, d equal the distance equal v 0 x times t1. Okay. Now, if t is the subject, it means this equation we can arrange becomes t equal distance over p0 x, or distance is this one 8.0 meters over p0 x. This one 6.16 meter per second, and the result is 1.3 second. Now, after that, the vertically motion, because if we are going to determine age, we have to using the vertically motion. The vertical motion is described by the equation h equal h0 or initial h. This is the initial h plus p0y times t minus half gt squared. So h or height equal 1.8. This is 1.8 plus 6.13. 6.83 if not mistaken. With to check this one. Okay, 6.83. 6.83. Wait. Yeah, I think that is clear. 6.83 times t. T is 1.3 minus half times 9.8 times 1.3 squared. And if you calculate, this is the result is 2.388 rounded to 2.4 meters. This is the height. Number three, a fixed quantity of 4.5 times 10 power minus 3 mole of air is compressed at a constant temperature. The graph shows the variations of pressure P with volume V of the air. This is the graph. Next. Suggest whether the air behaves as an ideal gas during this change. I have provided my explanation about this for an ideal gas undergoing an isothermal or constant temperature process. The pressure and volume are related according to the formula by Boyle's law. Okay, the formula is 1 PV equal 12. Okay, this means the product of pressure and volume remains constant at constant temperature. I'm gonna show you why this 12, because look, the relationship is 4 on this coordinate point. 4 times 3 is 12. 12, this coordinate point. 3 times 4 is 12. As well, this coordinate point. 2 times 6 is 12. And then this coordinate point. 1 times 12 is 12. So that's why the constant number is 12. Calculate the temperature of the air. We are going to using this formula that V equal nRT, which are P for pressure of gas and V volume of gas, N is number of mole of gas, R is an ideal gas constant. Okay, R is 8.31 joules. Okay. So R is the ideal gas constant, while T is temperature. So we're going to calculate the temperature. So if temperature, the subject, this formula becomes PV over N times R. Okay. PV is 12 according to the number A, number 3A. So it means 12 divided by n. N is n is 4.5 times 10 power minus 3 mole. According to this information, I'm going to show you this one. This is n. Okay, so is 4.5 times 3 times 10 power 3 times 8.31. And the result is 320.7, rounded to 321 Kelvin. The unit is Kelvin. Outline how kinetic theory of gases relates observable properties of gas to the motions of the molecules. I have provided as well my explanation about this part. The pressure is caused by the frequent collisions of gas molecules with the walls of their container. According to the kinetic theory, its molecule moves in random directions with varying speeds. When a molecule collides with the wall, it exerts a force and cumulative effect of many such collisions results in the observable pressure. The pressure is proportional to the number of molecules and their average kinetic energy. That's my explanation. Number 4, a solid block of glass is covered with water. The diagram shows the path of a monochromatic light ray entering the water from the glass block. This is the diagram. Uh, the angle of incidence in glass is 55. The angle of refraction in water is 71. The speed of light in the glass is 2 times 10 power 8 meter per second. Calculate the speed of light in the water. State the answer to an appropriate number of significant figures. Right. This is theta 1 and this is theta 2. So theta 1, 55, and theta 2 is 71. While, wait, This is the speed of light. The speed of light in glass. For me, this is the V1. Kalau the speed of light in water, so it means we are going to find V2. V2 is the speed of water, speed of light in water. This one. This is V2. Right. According to the Snell's law that sine theta 1 over sine theta 2 equal V1 over V2. If V2 is the subject, we can rearrange this formula becomes sine theta 2 over sine theta 1 times V1 or V2 equal sine theta 1 is sine theta 2, I mean sine 71 over sine 55. P1 is 1, 2 times 2.0 times 8, 10 power 8. And if you calculate, this is V2. V2 is 2.292 times 10 power 8. Appropriate number of significant figures rounded to 2.3. 0.3 times 10 power 8 meter per second. Part B. Explain the change in the wavelength of the light at the glass water boundary. I have provided my explanation about this. In the glass, the light travels faster and has a longer wavelength. According to the formula, this formula is lambda equals C over F, which lambda is the wavelength, C is the speed of light or light velocity, and F is frequency. When the light speed increases, when C increases and the frequency not change, F not change, so the implication the wavelength will be increased. I think clear. The light ray is partly reflected from the glass water boundary. Draw on the diagram the path of reflected ray. So the reflected ray will be still on the glass medium. It will be like this towards to downwards with angle 55 degrees. The water is removed and replaced with air. The refractive index of air is 1. The directions of the incident light ray in glass is unchanged. Okay, direction unchanged. Determine whether light emerges from the glass block into the air. Right. So if N2 refractive index of water 1.33 and theta 1 is 55. Wait. When is theta 1? Theta 2 is 71. According to to Snell's law, again, Snell's law that N1 is refractive index of glass. N1 is N2 sine theta 2 over sine theta 1. So if we substitute this data into this formula, N1 will be 1.33 times sine 71 over sine 55. The result is 1.52. This is the refractive index of glass. Now, if N air refractive index air is 1, after that the refractive index of glass is 1.52, and theta glass is 52, the angle of angle in glass. Theta glass is 55, I mean, not 52, 55. Okay. So according to the Snell's law, again, using Snell's laws, that sine theta glass over sine theta air equal n glass over n air. So if sine theta air, the subject, sine theta air, the subject, we can arrange this formula becomes n air over n glass times sine theta glass. So it means sine theta air equal n air equal 1 over n g is 1.52. Okay. Refractive index of glass, this one, and refractive index uh, of glass times sine theta glass is 55. So if you calculate sine theta air is 0.5389. 0.5389, it means theta air is 42 degrees. If 42 degrees, it is less than 90 degrees. 90 degrees. And the conclusion, if sine theta air less than 1, uh, the light can emerge from glass block into the air. Sorry. Number 5, a 50 ohm resistor is connected to a cell of electromotive force 3 volts. The voltmeter and the ammeter in the circuit are ideal. This is the diagram of a circuit voltmeter, and this is the ammeter. This is the resistor. The current in the ammeter is 59 milliamps. Calculate the internal resistance of the cell. Okay, so phi, I would like to identify that phi is the total voltage, okay? Total voltage or the total uh, the total voltage of this circuit, okay, or the electromotive force. I mean, this one, the total voltage or the electromotive force, and this is 3.00 volts according to this number. And current or I is the current of this circuit, and this is according to this information that uh, 59.0 milliamps. It means if we convert into amps becomes 0.059 amps. So I would like to using this number. Okay. And next is total resistance R. After that, the next step we are going to we can calculate this resistance through this formula that R equal that is better if using this EMF over I is 3.00 over 0.059, and the result is 50.85 ohms. And if there is another resistance, I would like to writing R like this, the external resistance. And according to information that the external resistance is 50 ohms. Now the total resistance, of this space, the total resistance is external resistance plus internal resistance. This is the internal resistance. Okay. So it means internal resistance equal total resistance minus external resistance, or 50.85 minus 50.0. And this is 0.85 ohms. So internal resistance is this one, 0.58. Next, the circuit is changed by connecting another resistor in parallel. Okay, so attach another resistor, this one, and attach by parallel circuit, parallel to this resistor, to the 50, to the 50 ohms resistor. Explain the effect of this change on the effect of this resistor to the reading of the ammeter, the implications of this resistor to the ammeter. I have provided my explanation, my opinion. This one, that when another resistor R, this resistor, the additional resistor connected in parallel with the 50 ohms resistor, supposed to be this 50 ohm resistor, the total resistance of the circuit will decrease. Why decrease? Because this circuit add more, add one more resistor, this resistor. This is because the total resistance of two resistors in parallel is always less than the resistance of either resistor individually. According to Ohm's law, if the total resistance decreases, the current through the circuit will be increased, assuming the electromotive force of the cell remains constant. Since the ammeter measures the total current in the circuit, the reading on the ammeter will increase after adding the parallel resistor. As the total current increase due to the reduced overall resistance. I think this is clear. Yeah, because based on the formula that current equal EMF over uh, external resistance plus internal resistance. If resistance decrease, okay, whether external resistance or internal resistance, the implication for the ammeter, the current the current or the ammeter will be increased. The measuring of ammeter will be increased. Right. Next. So what are the implications for the reading of the voltmeter? Just now, uh, when we when we add one more resistor here, this is the implications for the reading of the ammeter, and then next the implication, the reading of voltmeter. The reading of voltmeter, I have provided my opinion as well. The voltmeter is connected across the external resistor. In this case, across the parallel combinations of the 50 for the 50 ohms. So this is 50 ohms resistor, and the second resistor is R. Since the resistors are in parallel, the voltage across them, which is what the voltmeter measures, the voltage across them will remain the same regardless of the change in total current or resistance. The reading on the voltmeter will not change, okay, when the second resistor is added in parallel to the 50 ohms, suppose it is 50 ohms resistor. It will still show the electromotive force of the cell, which is 3 volts, 3.00 volt. The change in the circuit will only affect the ammeter reading, which will increase due to the decrease in total resistance, but not to the voltmeter reading. So just implication for the ammeter, but the voltmeter, there is no implication. There is no effect. Next. R is made of a resistive wire of uniform cross-sectional area, 3.1 times 10 power minus 8 meter square. Resistivity 4.9 times 10 power minus 7 ohm meter, and length L. The resistance of R is given by the equations. This formula R equal KL, where K is a constant. Calculate K. calculate the constant number. State an appropriate unit for your answer. All right, so the resistivity, this is rho, resistivity, and area, this is A. Okay, and then the formula, is R equal KL. Also, I would like to writing another formula of R is rho times L over A. Or we can arrange this formula becomes rho over A times L. So K equal rho over A. We're going to using this formula to find K. So K equal A this one, rho this one, 4.9 10 power minus 7 over this number 3.1 times 10 power minus 8. And the result is 15.8 rounded to 16. 16 ohm meter power minus 1. What else? Number 6. Okay. We're going to continue number 6. Number 6A. State what is meant by the half-life of a radioactive nuclide. Okay, for number 6, I have provided my solution, my opinion about this, my explanation that the time required for half of the nuclei in a sample of that nuclide to undergo radioactive decay. During this period, the activity or the number of decays per unit time of the sample decreases to half of its initial value. Yeah, that is the meaning of half-life of a radioactive nuclide. Right, next. Tritium is a radioactive tritium hydrogen 3 and this number of atom 1 is radioactive isotope of hydrogen. The activity of a sample tritium decreases to uh, this one, A0 over 8 after time 37 years, where A0 is the initial A0 is the initial activity. Calculate the half-life of tritium. Okay. So the activity decrease is 1 over 8 or half cube. Or it means 3 half-lives. Okay. So it means the tritium, half-life of tritium is 37 over 3 half-life. And the result is 12.3. Deuterium and tritium undergo nuclear fusions according to this reaction equation. Okay, identify nuclide X. All right. This is deuterium hydrogen 2, and then this one is tritium hydrogen 3. This one, and this is X is the unknown nuclide, and N is neutron. On the left side, the side of these equations on the left side, total total atom uh, total atom on the left side is the total atom is one one from deuterium and one from tritium. So total atom here on the left side, total atom equal to, okay. And then total mass on the left is 2 from deuterium, total mass 2 from deuterium and 3 from tritium. So total mass is 5. On the right side, on the right side, the mass number of X, the mass number of X plus the mass number of neutron should be 5 because this at the left side is 5. So it means the mass number of X, it should be 5 minus 1 equal 4. It should be 4 here, okay, because this is 1. And so X must have an atomic number of 2 because this 1 is 1. So this is supposed to be 2. So X has atomic number 2 and total mass should be 4, which means it is helium. If 2, it means it is helium, and mass number helium with mass number 4. Okay, so it means we can the conclusion this nuclide is commonly commonly known as alpha particle. It's alpha particle of helium-4. Yeah, helium-4, atomic number 2. The following data are given for binding energies per nucleon. That's data. This is X4 2. Okay. So that the energy released in these reactions is about 18 million electron volts. So energy release equal 4 times 7.074. Okay, 4 times this number plus 3 times 2.827 plus 2 times 1.112. And if you calculate, the result is 17.61 decimal places, rounded to 18 million electron volts. Outline why mass is not conserved, or is not conserved. Yeah, it is not conserved in this reaction. Why? It's not conserved. I have provided my solution, my answer, this one, based on Einstein equation. Actually, this is equation. Based on Einstein equations is E mc squared, or this is delta because it changed. So mass is not conserved in a nuclear reaction like fusion, because mass is conserved, because mass is converted into energy. It converted into energy. Through this, we can prove through this formula that delta n equal delta E over c squared. Number 7. In a simplified model of energy balance of the Earth, the surface of the Earth absorbs incoming solar radiations of average global intensity I0. The surface emits thermal radiations of average intensity I1. Some of the radiations emitted by the surface is absorbed by the atmosphere and re-emitted towards the surface. The average intensity of this radiation is I2. So I0 is the surface of the Earth absorbed incoming solar radiations of average. This is the global intensity. Okay. And I1 is the thermal radiation average intensity. And I2 is the average intensity of this radiation. It means I0 is I1 plus I2. Okay, the emit thermal radiation of average intensity plus the average intensity of this radiation. Okay, like this. So I1 towards to upwards, and I2 to downwards, I0 as well downwards. So I1 is I2, okay, plus I1 is I2 plus I0. Okay, we are going to calculate this. All right. So I1 equal I0 plus I2. I have to, based on this diagram, wait, based on this diagram, that I1, I0 plus I2. Okay. Next, explain the effect of an increase in the concentrations of greenhouse gases, GHG, in the atmosphere on I2. I have provided my solution, my explanation about this, my opinion, that with an increase in greenhouse gases, the atmosphere becomes more effective at trapping thermal radiation. This causes an increase in the intensity of, this is I2 actually, of I2. It's I2. The radiation that is absorbed by atmosphere and re-emitted towards the Earth's surface. This leads to an overall warming of the Earth's surface because the energy that would have been lost to space is instead radiated back to the surface, enhancing the greenhouse effect. This is my explanations about this question. Next, the following data are given. Now, I0 is 1, I2 is 1, as I written on upwards that I1 equal I0 plus I2 based on the diagram. Determine the average temperature of the surface of the Earth according to this model, right? It means I1 equal to 40 plus 150. It is 390. Okay. And then according to the Stefan Boltzmann law that uh, I1 equal sigma times T power 4, which T is temperature. And sigma is Stefan Boltzmann number 5.67 times 10 power minus 8. So it means T power 4 is I1 over sigma, or T equal I1 over sigma power 1 over 4. So T equal I1 is 390 over Stefan Boltzmann number is 5.67 times 10 power minus 8. It is 2.8 Kelvin. The unit is the unit temperature Kelvin. You may calculate this. You may make sure. Yeah. Number 8. A satellite orbits the Earth in a circular orbit of radius 1 times 10 power 7 meters. At the orbital radius of the satellite, the gravitational field strength due to the Earth is 4 meters per second power minus 2. Show that the orbital speed of the satellite is about 6 times 10 power 3 meters per second. Okay. Okay, I'm going uh, to calculate the orbital speed using this formula V equals square root G times R. It is square root of G is this one, gravitational field strength. So 4.0 times, and this is the radius, 1.0 times 10 power 7. Okay. And the result is 6,324.55. I would like to writing becomes 6, convert to, becomes like this, the significant figures, 3, yeah. Power 3, okay, meter per second. So the speed is this one, 6.3 times 10 power 3 meter per second. Calculate the orbital period of the satellite. The satellite orbital period, I'm going to using this formula that T equal D over V. V is velocity. D is 2 pi times R times radius over V. So 2 pi times 1.0 times 10 power 7. Okay, over velocity. Just now we calculate 6.3 times 10 cube. And the result is 0.996825 times 10 power 4. And in significant figures is 9.9 times 10 cube. Okay, unit is second.